Yes, welcome to the next session of Unix operating system. So now in the previous session we understood what is an operating system, how it is been bounded and what are its categorizations done. Now with respect to types, that is single and multitasking. So coming to single tasking systems, it can only run one program at a time, while a multitasking operating system allows more than one program to be executed concurrently. That is, for example, if I have a single user system, means a user can run only a single app or application or a task. For example, I can open a Word document. Till I finish the Word document, I cannot proceed with the presentation work or Excel work. That's single user, single task. Now multitasking is parallelly I'll be working something on Word document, I'll copy the content, I'll paste it on PowerPoint presentation. Same thing for some calculation or for graph generation, I'll get the data from Excel. So that is multitasking. This is about single and multitask with respect to an operating system. Next, single and multi-user. Single user operating system has no facility to distinguish users, but it can allow multiple programs to run. Whereas multi-user operating system extends the basic concepts of multitasking with the facilities that identify what are the process that is being executed and what are the resources that is being allocated for each and every process. And there's a concept called as resource scheduling or process scheduling that can be effectively utilized and understood in multi-user operating system. Next is distributed approach. A distributed operating system manages a group of distinct computers and make them appear as a single system, wherein, for example, if I have to execute a particular process in a distributed approach, the process is being executed in a distributed way. That is, for example, I have 5 systems, 5 processes been divided among all the available 5 systems, and task is being executed in parallel. So efficiency and time will be good. Next, embedded operating system are distinguished to be used in embedded computer system, and they are designed to operate on a small machines like your micro oven, washing machine, refrigerator. So everything is functioned with a predefined program that is embedded inside a system, that we call it as embedded operating system. So that has a predefined task and which cannot be altered by the users. Now seeing this diagram, we'll get a clear picture on what we have understood till now. That's we have a basic hardware, that is CPU with RAM and input output devices. On this hardware I have something called as software. What is this software? Two parts, that is system software and application software. So system software is nothing but my operating system, and application is the one which is developed by the user to operate on operating system. So this application software will make use of the hardware through operating system, and there can be one user or there can be many users. Hope this is clear. Next we'll go to important functionalities, like first one is memory management. Memory management refers to management of primary memory, or it can be a main memory, that is RAM. Main memory is a large array of words or bytes where each words or byte has its own address. So that's by default, we all know memory means it's indirectly referred to as address. Main memory provides a fast storage that can be accessed directly by a CPU. For example, now I have a C program that has been written and saved in my D drive. Now I want to execute using my terminal. Now when I give cc space filename.c, data from a D drive is being taken, that is D drive is secondary storage. From my hard disk is being taken to primary storage, that is my RAM, and from RAM it's been executed through compiler. Now when I compile and I execute some answer, I make modification, everything will be temporarily stored in a primary storage, that is main memory. Once execution is terminated or process is killed, it's been dumped back to the secondary storage, that is permanent storage. For a program to be executed, it must be in main memory. Fine. Allocation and deallocation also is an important task of memory management, right? Process management. So that was previously memory management, and now we are with process management. Process in multi-programming environment, the operating system decides which process gets the processor and when and how much time it needs to be utilized. This functionality is called as process scheduling. That is, I can have n number of processes which are in a queue, first come first service, first come first serve, or based on some priorities, processor can be allocated for each and every process. An operating system keeps track of all this information and status of each and every process. Why? Because it has to do the allocation and deallocation of processor to each and every process, right? Device management. Next task is device management. An operating system manages device communication via respective drivers. For example, In an instance, we have a pen drive. I insert a pen drive into my Mac machine or any operating system machines. So it's like a plug and play approach. That is, I'll insert, automatically it will open the content of the pen drive. I can access, I can download, I can copy, paste, many operations. There is no program written by the user and executed by the user at the time of insertion of a pen drive. So it's automatically done by the operating system. So that is nothing but device driver program which is already embedded in a framework called operating system. So that is the functionality through which device management can be done. So this task we can call it as input output controller, decides which process gets the device when and how much time it has to use the devices. Allocation and deallocation of the same has to be monitored and maintained in device manager. Next, very important with respect to our Unix is file management. File managed system is normally organized into directories for easy navigation and usage. These directories may contain files and other directories. I repeat, this directories what we are discussing contains many files. Also, it can contain directories called as subdirectories. Operating system keeps track of this information, location, user status, and this we collectively call as statistics of a file in a file system. Decides who gets the resources, allocation and deallocation as usual is also monitored. So coming to other important activities of operating system, security. Security is one which is done via user authentication. It can log in, log out aspects. Next is control over system performance by efficiently allocating the process or scheduling the process, or in general we call it as process scheduling. Next, job accounting is for assigning each and every resources, putting process in queue and executing one by one as in request. Error detection, if any error occurs with respect to a resource or with respect to a process or with respect to time, it is been detected and proper precautions can be taken. Coordination between the software and the users is also monitored and managed. Next we have components of Unix that we'll take up in the next session. So till now I hope you have understood about the basic operating system concepts, followed by activities like memory management, process management, device management and file management with other basic activities. Thank you.